For this example, we have an equation that is in standard form, but I want us to solve this for y, putting it in slope-intercept form so that we can graph using the slope and the y-intercept. So the first thing we need to do to solve for y is to move the 2x to the other side. Right? I'm sure we've done this plenty of times in our pasts. So now we have negative 3y is equal to negative 2x plus 12. And then we want to finish getting y by itself by dividing both sides by negative 3. So there we go, divide both sides by negative 3. And y is equal to, make sure you pay attention to your signs, this is going to become positive 2/3 x, and this becomes negative 4 when you reduce, right? Negative divided by negative is a positive, and a positive divided by negative is a negative, so please make sure you pay attention to your signs. Now that we are in slope-intercept form, we can clearly see that our slope is that coefficient of x now, which is 2/3. We could not have pulled off the slope from the very beginning because we didn't have this solved for y. Now that we do, this is my slope. Remember that the slope is just going to be the coefficient. It doesn't actually include the x. And we see this as rise over run. And then we take a look at our constant term. And that directly relates to our y-intercept, and it gives us the ordered pair 0, negative 4. And when we graph with the y-intercept first. So 0, negative 4 is right here. And we use the slope 2 over 3, so we go up 2 over 3, up 2 over 3, and we do that until we run out of room. And then we go to the left side to get more points. So down to left 3, just like this. And now we just connect the dots. I don't know why, but this is just incredibly satisfying to just draw the line through those points. Feels good, right? So we're saying that each of those points is a solution to the original equation. So if you were to pick these guys off, for example, this one down here, which is the ordered pair negative 6, negative 8. This should be a solution to this original equation. So let's check that out. If I do 2 times negative 6 minus 3 times negative 8, what do I get? Well, this is negative 12. Negative 3 times negative 8 is positive 24, and that equals positive 12, which is exactly what I was supposed to have. No matter what point you pick here, it's supposed to be true in that original equation. All right? Now, for this next problem, I want to look at things just a little bit differently. So here we have 5x plus 4y equals 20. And what I want us to do is I want us to identify first the x-intercept and the y-intercept. There will be problems that you come across in the homework where they ask you for the x and the y-intercepts, and they're going to ask you to graph using those 2 points. Now really when you graph a line, it just takes 2 points, and as long as you draw the line through those guys, you should be fine. But when they ask you specifically to graph using the intercepts, you've got to make sure you plot those guys for your points. Let's make sure we understand what we know about every x-intercept. Every x-intercept is going to be something comma 0, because you have to be on the x-axis, which means your y-coordinate has to be 0. And for every y-intercept, if you're on the y-axis, your x value has to be 0, because if x is not 0, you're going to be to the left or to the right, and you wouldn't actually be on the y-axis. Knowing this information and knowing how we completed order pairs when we were reviewing the rectangular coordinate system, this really shouldn't be too bad. So here, if y is 0, that means 4 times 0, and that's 0, so that guy goes away. And you're left with the equation to solve, which is 5x equals 20. So when y is 0, this guy becomes 0, he's gone, 5x equals 20. Which, when you solve for x, x equals positive 4. So that's how we can complete the ordered pair. And you have something very similar going on here with the y-intercept. When x is 0, 5 times 0 becomes 0, so he goes away, and we have 4y equals 20, which means y, when you divide by 4, is 5. So you can complete the ordered pair, and you have 0, 5. Now taking those two ordered pairs will help us get everything else we need for this graph. The x-intercept goes on the x-axis, so that's 4, 0. The y-intercept goes on the y-axis, that's 0, 5, so that's up here. To get more points, let's calculate the slope. Let's find that rise over run. So as I go from here to here, what am I doing? We're going down 5 over 4. If we do that again, we go down 5 and over 4, and we land right here. You can try to reverse that. Go up 5, left 4, up 5, left 4. If we go up 5, I'm going to be off the graph a little bit. We can probably match up with something that's really close to being right there. And now we just use our straight edge, and we connect the dots. Yeah, sometimes depending on how large you make the dots, it may be hard to line them up and things don't necessarily look right. Here we go. Of course, at the end of the day, you want to make sure that your solutions are correct and pick an ordered pair and plug it back into the original equation to see if that works. So here you have 8, negative 5. You plug in 8, negative 5, and that's going to work out. But there's something else I want us to do. I want us to take this equation and I want us to solve it for y so that we can see, even if we put this in slope-intercept form, how everything is still going to be the same. So let's rework this. 5x plus 4y equals 20. And let's solve this for y. So the first thing you would do would be to move 5x to the other side. So 4y is equal to negative 5x plus 20. And then we divide both sides of the equation, everything here, by 4. So y is equal to negative 5/4 x plus 5. You notice here that we have the 5, which corresponds to the y-intercept 0, 5, so that does match up. And the slope is negative 5 over 4, which means you would go down 5 over 4, just like we established the first time.